SEPIA is a way to measure the control loop stability of a power converter without breaking the feedback network. We can measure it on the oscilloscope. Tony, why don't you tell us what's going on with these waveforms?
All right, well, we have the setup on here, and we're basically applying a step to this device, and we get the rail voltage on here, and we're able to filter that so we get a cleaner waveform in order to make measurements, because we want to look at the peaks on the ringing to be able to determine what the Q factor is, and from that the phase margin, L and C, and things like that.
So with the filter waveform, we get the phase margin and the Q factor.
Right.
So in this case, we have a DUT that allows us to optimize its control loop. Tony, I think you have some software that allows us to automate that. Is that correct?
Correct. So MPS has their software. It allows you to have different settings that you can change to be able to modify capacitance, resistor values, and things like that. So there's a lot of different things that you can change, and there's a lot of parameters that you end up having to go through. So I figured, okay, well, since we have the measurement on here, let's figure out a way to talk to the device and automate that so it can run through all the different settings. So I just did a simple example where we manually set up 3 settings. So we figured out what was going to be our worst result, a better result, and the best result.
So let's go take a look at your software. This software is able to control this MPS device, correct? And I think you said you have 3 different profiles in this software. So you can automate the configuration of this DUT and we can see the results.
Absolutely.
All right, let's take a look.
All right. So we're already connected. We just hit run optimization, and it's going to load in all the registers for the bad setup. And then we're only going to modify the parameters. So we take this, and we see the bad result. Now we see the step response change. We get a little bit of a better result, and we modify those parameters. So basically taking the single acquisition, we're actually doing some averaging to clean up the waveform. And then we finally, the final one gives you the cleaner response. And now we tell you exactly which settings were the best ones. We're based upon the Q factor of being 1 or less, and a phase margin between 45 and 55.
You know, Tony, I think this is really interesting because SEPIA is already a fast and accurate way to do control loop stability measurements. And I think your example of controlling this DUT and automating allows an engineer to quickly find a configuration that works well for them.
Yes, hopefully to save time. Help you go home on the weekends.
All right, if somebody wants to learn more, where can they go?
Head over to tech.com.